All right, welcome to the Explainer. Today we are tackling a huge topic, something that's totally changing the game in cloud technology, serverless computing. And we're going to be looking at it through the lens of a really important paper from UC Berkeley that pretty much gives us a map of where the cloud is going. So let's just jump right in.
To really get our heads around this, we have to start with this idea. It's a quote from a Google engineer, Luis Barroso, and it's so perfect. The data center is now the computer. Just think about that for a second. We're not programming one little machine anymore. We're programming this massive global network of warehouses filled with computers. And that, of course, leads to the big question, right? If the whole data center is the computer, how on earth do you even begin to program that thing? I mean, it is wildly complex. For years, developers have basically had to be part-time system administrators, constantly messing with virtual servers and networks. It's a massive, massive headache.
And that complexity, that whole mess, is exactly why the Berkeley researchers say we are right in the middle of a huge evolutionary leap, a whole new way of programming the cloud that promises to make everything way, way simpler.
Now, to get what this leap feels like, it helps to know that we've actually seen this movie before, just in a different part of programming. Think about the old days. We went from writing in low-level assembly, where you had to painstakingly manage every single bit of memory yourself, to using high-level languages like Python, where all that memory stuff is just handled for you. It's automatic. That abstraction made programming a million times easier for everyone.
And that is the perfect analogy for what serverless is. It's the exact same kind of jump, but for the cloud. We're moving from what we now call server-full computing, where you're deep in the weeds managing servers, to serverless computing, where all of that nitty-gritty infrastructure stuff is just taken care of for you by the cloud provider.
Okay, so what is serverless really? The Berkeley paper breaks it down into two main parts. First, there's FAS, or Function as a Service. This is kind of the core of it. You just write a small piece of code, a function, and you toss it up to the cloud. The cloud provider then figures out everything else needed to make it run. And then there's BAS, Backend as a Service. These are like pre-built Lego blocks for complex stuff like databases or user logins that you can just plug into your app, again, without touching a single server.
So you can see how this totally redraws the lines of who's responsible for what. It creates a brand new division of labor between you, the developer, and the cloud. Let's dig into what that actually looks like.
Just look at this breakdown. It is night and day. In the old serverful world, you are on the hook for practically everything. Making sure it scales, handling failures, patching security holes, it's all on you. But with serverless, nope, that's the provider's problem now. And the billing part is just wild. You go from paying for a server by the hour, even when it's just sitting there doing nothing, to paying only for the 100 milliseconds your code is actually running.
So really, it all boils down to this one simple idea. With the old model, you have to be both a system administrator and a programmer. Serverless lets you forget all that admin stuff and just be the programmer. It just gets out of your way so you can focus on building cool things.
And believe me, this isn't some far-off futuristic theory. It's happening right now, powering tons of real applications. You can see here a huge chunk of it is for running web backends and APIs, which makes a ton of sense. But people are also using it for all kinds of data processing, for stitching together different services. It's everywhere.
But it can't all be perfect, right? Of course not. Like any new technology, what we have today has some serious growing pains. It is not the solution for every single problem out there. At least, not yet.
Which brings us to the million-dollar question. If this stuff is so much simpler and can be way cheaper, why isn't everything serverless by now? Well, that's exactly what the Berkeley researchers set out to discover. They basically took today's serverless platforms and pushed them until they broke, just to see where the cracks are.
And yeah, they found some major roadblocks. The first one was storage. It was just too slow for all these little functions to share data with each other quickly. There was also no good way for functions to coordinate with each other. And performance, it was all over the place. You've probably heard of the cold start problem. That annoying delay the first time a function runs? Yeah, that was a big one.
When they really dug in, they found that a lot of these problems all pointed back to one single massive bottleneck: storage. See, serverless functions are what we call stateless. It's a fancy way of saying they have the memory of a goldfish. They forget everything the instant they're done running. So to remember anything, they have to rely on some external storage. And that storage just isn't fast or flexible enough for the really demanding applications.
But here's the good news. Once you know what's broken, you can start figuring out how to fix it. And that's exactly what the paper does next. It lays out a clear roadmap for what the future of serverless needs to look like.
So to fix that huge storage problem, they say we basically need two totally new kinds of storage designed from the ground up for serverless. First, something they call ephemeral storage. Think of it like a super-fast temporary scratchpad that functions can use while they're working together. Then, you also need a new kind of durable storage, something that's both permanent and incredibly high performance for the data you need to keep around.
And it's not just about storage. The researchers also say we need a much better way for all these functions to talk to each other directly and instantly, like a super fast private messaging system so they can coordinate their work without any delays.
Okay, so imagine a world where we fix storage and we fix how functions communicate. What happens then? Well, this is where the paper gets really interesting and the researchers make some huge, bold predictions about the future.
They're not just saying serverless is going to be another tool in the developer's toolbox. No, their argument is way bigger than that. They predict it will become the dominant way we build things on the cloud, a fundamental reshaping of everything.
So here's what they see happening in the next decade or so. 1. Serverless becomes the default. It's just how we'll build things. 2. Those new storage services we talked about will unlock all sorts of powerful new applications that aren't possible today. 3. The billing will get so good that serverless will be cheaper than the old way for pretty much any workload. And what about the old school server full computing? Well, its main job will just be to run the very back-end services that the new serverless world is built on top of. Kinda ironic, right?
And they end with this absolute bombshell of a statement. They say serverless will bring closure to the client-server era. I mean, think about that. The client-server model has been the bedrock of computing for like 40 years. It's the foundation of the entire internet. And they're saying serverless is what finally ends that era.
And that's the thought I want to leave you with. That client-server era built the entire digital world we live in today. If that fundamental model is actually going away, what comes next? What entirely new, unimaginable things will this new serverless era build? It's a pretty wild thing to think about. Thanks for diving into this with me today.